Electric circuit symbols. We use standard symbols to simplify drawing electric circuits. You're expected to know the following symbols. This is an open switch, which when open has infinite resistance and stops the current flowing. This is a closed switch, which has zero resistance and allows the current to flow. This is a cell, just one of what we'd call a battery in everyday life. And conventional current, we say, flows from the positive terminal, the longer arm, to the negative terminal, the shorter arm. This is a battery, which is made up of two or more cells. This is a diode. A diode only allows current to flow one way, and it's this way, so the triangle here you can treat as an arrowhead, allowing the current to flow along the arrowhead. This is a resistor, which obeys Ohm's law, that is the potential difference is equal to the current times the resistance. This is a variable resistor. All resistors have the rectangle. The variable resistor has the rectangle with an arrow going through it. This is an LED or light emitting diode. It operates just the same as a normal diode, but lights up when current is flowing. The arrows here are representing light being emitted. The rest of the symbol is the same as the ordinary diode here. This is a lamp. This is a fuse. Note, if you draw a resistor on an existing wire, it would give the fuse symbol. So you'd need to either rub out this line along the middle, or you could shade in the rectangle to hide the line in the middle. This is a voltmeter, which goes in parallel and measures the potential difference between 2 points. An ammeter is fitted in series and measures the current. This is a type of resistor, as it has a rectangle, and it is a thermistor. With a thermistor, the resistance falls as the temperature rises. This is due to the release of many more charge carriers. Here, the arrows here represent light coming in. The rectangle represents a resistor. So this is a LDR, or light dependent resistor. The resistance falls as light levels rise. The light energy releases many more charge carriers, allowing the current to flow more easily. Components should be joined by straight, horizontal or vertical lines representing the wires, something like this. When building a circuit, it helps to lay the components out as close as possible as how they appear in the diagram. Then build complete loops, always working from positive to negative. So on this circuit, I'd start at the positive terminal here and connect a wire to one side of the ammeter. From the other side of the ammeter, I'd go to the lamp, from here to the next component, in this case the light dependent resistor, then back round to the negative terminal of the battery. That's one loop completed. I could then go from this side of the circuit, either connecting to the positive side of the battery or to this side of the ammeter, and going to this side of the voltmeter. From the other side of the voltmeter, I can come back to either the negative terminal of the battery, or I could connect to this side of the light dependent resistor. Next, I can come from here, which will actually be connected to this side of the ammeter, or this side of the lamp, to the voltmeter, and from the other side of the voltmeter to the other side of the lamp. And finally, from this side of the light dependent resistor to the voltmeter, and from the other side of the voltmeter to the other side of the light dependent resistor.